Hey guys, it's Off1 here, and today we're going to be solving number of islands. In this problem, we're given a 2D grid, which is represented in ones and zeros, where 1 is land and 0 is water, and they want us to return the number of islands. So what is an island? An island is defined as being surrounded by water and formed by connecting adjacent lands horizontally or vertically. So what that means is that diagonal lands like these two here do not count as one piece of land. So for example, this would be one piece of land, and this would be another piece of land. And the third piece of land would be this. So now that we understand what an island is, let's get into the solution. So here I've redrawn the example from the problem, and I think a fair place to start would be by saying that we want to search the entire grid here. So let me just write that down. Okay, but what do we want to do while we're searching this entire grid? Well, we know we want to search for an island, but how do we do that? Well, we know we can only have an island if we encounter a 1. So we can say while we're searching the grid, if we encounter a 1, then that means we encountered an island. But let's say we start at this 1 here. There's a lot of other ones that are connected to it, and this whole thing here is what makes an island, not just this one. So we have to consider all the rest of these ones and how to account for them. So what we can do is actually a depth first search. So for example, let's say we started this here. We can visit the node next to it and the node below it and do a DFS from there as well. So we can do DFS for these two nodes, and then if we go below this node, we see there's a 0, so that wouldn't be part of the island. But if we check the node next to it, we see that this is part of the island. So this whole square here would be an island, and what we can do is mark them as visited, so we don't visit them again. And just as a side note, whenever I say node, I'm referencing the grid itself and not some actual node object like we've done in previous problems. So let me just summarize what I just said. So if we encounter a 1, like here, we want to do a DFS. So we want to do a depth first search. So let me just write that down. Okay. And then once we do the DFS, then we want to go all the way recursively until we find all the zeros that are on the edges of it. And once we find all zeros, then we know we found a whole island. So our goal with this algorithm is to be able to count how many times we run this DFS algorithm. And this is basically the entire algorithm. So let's say we're doing DFS for this node here, and that no other node is visited yet. What we want to do is visit the one above it, the one to the right, below, and to the left. And if we encounter a 1, then we want to do the same thing. We go for every single coordinate around it, and if we haven't visited it, and it's a 1, then we do the same thing over and over again. If we have a 0, then we stop our DFS algorithm. And the way we're going to mark nodes as visited is just by zeroing out whatever is the value. So obviously we only have 1s and 0s. So if you make it a 0, then we're never going to visit it again because it's a 0 and we don't run DFS unless we encounter a 1. So this would also be a 0. And then once we visit these nodes, these are also going to be 0. And as you can see, we have 2 rows of zeros now, and we encountered 1 island so far. And if you keep doing this algorithm, we'll run into this 1 here, and then eventually that'll be zeroed out, and we can increase our count to 2. And now if you run the algorithm again for this row here, then we see we're done because it's all zeros. And for the last row, we see we have this 1 here. We'll run DFS for it and see that we only have one other 1. And once we do that, we mark these 2 as 0 as well. And now our count is 3. And that is how many islands we have. So to summarize one last time, what we're going to do is search the whole grid row by row. And then if we encounter a 1, then we want to run our DFS algorithm. In our DFS algorithm, we're going to search every node that is adjacent to it. So the node above it, to the left, down, and to the right of it. And then in this DFS call, we're going to zero out the node we're currently visiting because that means that we already visited it and we don't need to go over it again. Once we find all the zeros on the edges, then that means we found a full island and we can just increase our count of islands. Our time complexity for this algorithm is going to be O of n times m because we're only going through the grid once and the grid is of size n times m. So that's why we have this complexity. Our space is going to be constant because we're not using any data structures. We're only changing the grid itself in place, so we don't need any additional storage. So now let's get into the code. To start, I'm going to define the number of rows as the length of the grid and the number of columns as the length of grid at index 0. And that's going to tell us how many rows and columns we have, just to make the code a little easier to read. And then we're going to iterate through the whole grid. So we're going to do for row in range of rows, we want to iterate through every column. And from here, we want to check if the current coordinate is equal to 1. So we're going to do if grid at this row and column is equal to 1 as a string, by the way, because that's how the problem is formatted. Then we want to run our DFS. But we haven't defined our DFS yet, so let's do that first. So we're going to do define DFS, and we want to pass in just the row and column. And from here, we can just do our algorithm. And we can break this up into 3 steps. First, we want to do our checks to make sure we're in a valid position. And then we want to do our marking as visited. And at the end, we just want to run DFS as needed. So let's start. Our checks are going to be to first check if we're in bounds. So we're going to do if row is less than 0 or column is less than 0, then that means we're out of bounds. And vice versa, we don't want to go too high. So we're also going to do if row is greater than rows minus 1, or if column is greater than columns minus 1, then that also means we're out of bounds. And if we're out of bounds, we just do a returned, because we don't need to do any DFS for that. Next, we want to check if our current coordinate is 0, because if it is, then that means we don't want to run DFS for that. So we check if grid at our current row and column is equal to 0, then we also do a return. So now we're done with our checks, and now we can just mark our nodes as visited. And how do we do that? Well, like I said in the example, all we're going to do is set our current coordinate equal to 0. Just like that. And then next, we can just run DFS as needed. And for this problem, we're going to need to go to every single adjacent node. So we're going to go above, below, to the left, and to the right. And the way you do that is by going to DFS at row column, but slightly modified. So to go above, we do row plus 1. To go below, we do row minus 1. To go to the left, you go row or column minus 1. And then to go to the right, you do column plus 1. So that's it as far as our DFS algorithm goes. So now we can go back down here and finish our DFS call. So we're just going to pass in our row and column. But like I said, every time we call this DFS, we want to keep a count. So we want to increase our count by 1. And we also have to initialize our count to 0 here in case we don't find any ones. And then at the end, we can just return our count. And then that should work. So as you can see, this code is pretty efficient. And now I'll go through the code manually. So for this code, we're going to start down here immediately because this top part is kind of irrelevant. So we're going to have our count initialized to 0, which we already have here. And then we're going to iterate through every single point in the grid. So let's start. If our current point is equal to 1, which it is here in the top left, then we want to run this DFS and increase our count by 1. So let's just increase our count first. And now let's run the DFS. So we're going to run DFS on this. And as you can see, it passes our checks. And then we want to mark it as visited. So now this node is going to be a 0. And we do DFS for the left, above, to the right, and below. But we already know that to the left and above just give us out of bounds. So we're going to skip that part. But we are going to go below and to the right. So now we're going to run DFS on these two. And let's just do it for this one on the right. So we're going to check if we're in bounds, and obviously we are. And it's not a 0, so we're good there. So we're going to mark it as visited. So that's going to be a 0. And now we do DFS for every single adjacent node. So we're going to go below, to the right, above, and to the left. But as you can see, the one to the left is 0 now, and above is out of bounds. So now let's go to this node. So we see that it's a 1. So our checks pass here. And now we want to mark it as visited. So we're going to convert this to a 0. And now we want to do DFS for every node adjacent to it. So we're going to go to the left, down, to the right, and above. But as you can see, these are all zeros. So we would just get a return value here. And that's it for this DFS call. Now let's go over here. So for this DFS call now, we pass our checks. And we just have to mark it as visited now. So this turns into a 0. And we do DFS for every node adjacent to it. So we're going to go down, and we see that it's a 0. And we're going to go to the right, and we see that it's a 0. And I didn't do it for this one, but also we go down and to the right, and these are both 0. And up here as well is a 0. So that's why our DFS call would end now. And now we can increase our count, which we already did. So now let's go to the next coordinate. The next coordinate will be this here, and we can see that it's a 0 now. So we keep going, and we see more zeros and more zeros until we get to this one here. When we get to this one, we want to do our DFS call. So we're going to go into DFS, and we see that it's in bounds and it's now 0. So we want to mark it as visited. So now this turns into a 0. And we do DFS for above, below, to the left, and to the right. So if you go above, we see a 0. If you go to the left, we see a 0. If you go to the right, we see a 0. And if you go below, we also see a 0. So that's it for our island here. So now we can just increase our count to 2. And then from here, we keep iterating through the grid, and we see that we see more zeros, and then finally we see this 1 over here. So we're going to run our DFS call again, and we see that our checks pass. So now we're going to mark our node as visited. So we set that equal to 0, and we do DFS for every single adjacent node. So we're going to check above us, to the left, and to the right. And as you can see, the one above is 0, the one to the left is 0, down would be out of bounds, and then to the right we see a 1. So since we have a 1, we can go past these checks, and we can mark this current node as visited. So we make it into a 0. And now we do DFS for every single adjacent node. So we go above, and we see it's a 0. If we go to the left, we see a 0. Below it's out of bounds, and to the right is out of bounds. So now we're done with that DFS call, and we can just increase our count to 3. So now that we're done with this coordinate here, we want to check our last coordinate at here at the bottom right. And we see that it's a 0 because we zeroed it out for this DFS call. And we can just return our 3 at the end because we're done with our iterations. And we know this is correct because we can see here that we have 1 island here, 1 island here, and 1 island here. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.